The diagram shows a right angle triangle and three circles. So the right angle triangle is shown here. That's the right angle triangle, and the three circles. So this is the one of the larger circle. So there's a larger circle. So if I call this L, and then they have this circle, the next circle, so I can call this circle M, and then the smaller circle finally I'd call it N. So this is a circle, and then it says each side of the triangle, the right angle triangle, so this is a triangle. So then it says that each side of the triangle is diameter of one of the circles. So each side, so therefore what it would mean is this is the diameter of the circle L. So what I would do is I'd mark the center of the circle, easier to work that way. So if I call it O, and I'd mark the center of the other circle, the circle M, and if I call it P, and the center of the circle N, if I call it Q, then the shaded region R is a region inside the two smaller circles but outside the largest circle. Prove that the area of R is equal to the area of the triangle. So what does that tell me? That tells me that we have to find, we have to prove that the area of this shaded area, so if this one was, suppose this is R1 and this is R2, then R equals R1 plus R2. That's not what we have to prove. That's what I'm saying. I've marked them, separated the two shaded areas in the two circles as R1 and R2. What we have to prove is R equals area of the triangles. If I name the triangle A, B, and C, so the area of triangle ABC. So that's what we have to prove. So write down, so R equals R1 plus R2. That's what we are going to prove, and that means, and that would be equal to area of triangle ABC. So that's the requirement. What else do we need to do to prove that? We need to assume some things. That is, we need to assume the radius of these circles. So suppose a radius AO is it's A, and OC is also A, and the radius of the circle M, that we can put as B. So AP is B and PB is also B. So the diameter would be 2B and the diameter of L would be 2A. And then the radius of the circle N is C and C. Okay, so that's done. The next thing I would do is we need to get some angles, because obviously we'd have to find the area of the sector. So we need the angle. So we're going to mark some angles. So one of the angle we're going to mark is join OB. So we have, this is angle theta. So obviously triangle OBC is isosceles, and OC is A. So OB would also be A. And angle AOB would then be 180 degrees minus theta. Now they're all in degrees, okay? Theta degrees. So I think we are ready to start. If you need some more things to be marked, I'll do that. So the first thing is, if I to find the radius of R1, okay? So what is the R1? So R1 would be, so this is R1, so R1 would be equal to the area of the semicircle N minus the area of the segment BC, which is this part really. So area of the semicircle, and we know it very well. So that would be pi c square divided by 2, and then minus area of the segment BC. So we'll do a bit of work here. First of all, that would be area of the sector OBC. So area of the segment BC would be the area of the sector OBC, which is this part. So this is the sector OBC minus the area of the triangle OBC. So that's what we are going to do. So sorry, this line drawing went away. So line again. Yeah. So and then that's done. So then minus, so area of the sector OBC. I will write it down so it's easier to understand. Minus area of triangle OBC. Now we don't really need to worry too much about calculating the area of the triangle, so I'm going to do some assumption again. So then I'm going to take the area of triangle OBC is A1 and the area of triangle AOB is A2. So assume triangle OBC equals A1 area and triangle AOB equals A2 area. So the area of triangle AOB is A2 and OBC is A1. So then we can complete this so that the area of the sector OBC would be theta out of 360 degrees times pi a square minus A1. So I'm going to write that here. Theta in brackets, of course, out of 360 degrees times pi a square minus A1, and that equals pi c square out of 2 minus theta out of 360 degrees times pi a square plus A1, removing the brackets. And once we get that, now similarly we are going to write what R2 should be. So this is R1. Now I can write what R2 would be. R2 would be, instead of pi c square, now it is pi b square, because R2 is here. So, and the diameter, the radius is b. So therefore we will write that it is pi b square out of 2 minus what is the area of the sector AOB. So the angle is 180 minus theta, so it would be 180 minus theta out of 360 degrees times, again, pi a square, and minus A2, because A2 we've said is area of the triangle. So if you remove this bracket, it would be um, that equals pi b square out of 2 minus 180 minus theta out of 360, then all degrees, times pi a square plus a2. So now we have to add r1 plus r2. So r1 plus r2, this, before doing that, is another thing that we have to do in triangle ABC. The triangle ABC is right angled, so we can write here that triangle ABC is right angled. Okay, so therefore what we can do is, in triangle ABC we have 2b whole square plus 2c, because c plus c, 2c whole square equals 2a whole square. And from this bit what we can see is, therefore 4b square plus 4c square equals 4a square, and therefore b square plus c square equals a square. We get this by Pythagoras. So that's the next, what we can do is we will add, so r1 plus r2, and that is r, and that equals pi c square out of 2 minus theta out of 360 pi a square plus a1 plus pi b square out of 2 minus, now this expression 180 minus theta out of 360 pi a square, this expression we're going to break it down. Okay, so we break it down to minus 180 out of 360 pi a square and plus theta out of 360 pi a square plus a2. It's a bit big, but I think we can make some progress with it. So we first look for cancellations, and that's here. One of them go out, theta out of 360 and theta out of 360 pi a square. Now you see 180 out of 360, we can rewrite it as 1 out of 2. So then writing it again, we will say r equals, we have pi out of 2, if we take common outside the bracket, then we are left with c square, so that's this term done, then plus b square, that's this term done, and then minus a square, minus a square, that's this term done. So we are now left with only a1 and a2, so plus a1 plus a2. Now you see c square plus b square, we have already done it, is a square. C square plus b square is a square, we've got it from over here. So we can write that equals pi out of 2 times a square minus a square plus a1 plus a2, and that equals a1 plus a2, and therefore r equals a1 plus a2, area of the triangle. ABC, and that's proved.